Hey class, let's go ahead and keep continuing with 12.1. And let me go ahead and open this up for you guys. Okay, so now we're going to talk about if the linear relationship is significant. Because just because it has a linear relationship doesn't mean that we're going to really look at it and value what it's saying. So one way to do this is using the critical value of the Pearson correlation coefficient to determine the significance of a linear relationship. So we say if a sample correlation coefficient R is statistically significant if the absolute value of R is greater than or equal to R alpha. So let's go back to our data set and let's look at that. Remember, we found the R for the number of passing touchdowns and the base salary using the 0.05 level of significance. So the first thing you're going to do is you get a new table. It's table I in the back of the book. You have a significance value of 0.5 and your N is 10 because, you can't count X as individuals and Y as individuals. You have to count them together. So having an X and a Y, you have 10 data values. Don't count the 10 for X and the 10 for Y and put 20. There's only 10 for this. So if we go look in the table, we see we go down to 10. We go across and significance level is 0.632. So let's compare those. So we found on this one that this was negative 0.065. But then what we need to do is then take the absolute value, okay? So 0.251 is what? It's less than 0.632, because remember, we did this before, and we need to take the absolute value. So what does that become? It becomes a positive, and then we compare it to the R critical value from the table. So again, this value right here is from the table, and I'll put it there so you can remember. Okay, so we're going to do the absolute value of R is less than the R critical. Okay, because it is, we can say it's not statistically significant at the 0.05 level significance. So how to put this in the proper terminology is say, we do not have sufficient evidence at the 0.05 level of significance to conclude that the linear relationship exists between the number of passing touchdowns to the 2011-2012 season and the 2012 base salary of an NFL quarterback. Okay, well, let's do it for the next. Let's do it for this. We're going to look at hypothesis testing. So we're going to take this a little bit further because what we just did was to see if it's significant. Now we can use significance and hypothesis testing. These are look really familiar because we've done these before in Chapter 10, but now we're looking at it very different. So, for a two-tailed test, which means all I want to know is if there's a significant linear relationship, my null is P equals 0, my alternative is P does not equal 0. Negative, which is saying it's a left-tailed test, left-tails means less than, so remember null is P is greater than or equal to 0. The alternative is P is less than 0. And they give you the English out beside it showing that P does not equal, there's no significant negative and there's no significant linear for the bottom. Because what we're looking at is sometimes you want to know if there's a negative linear relationship and sometimes you want to know if there's a positive linear relationship. Or you just want to know if there's a linear relationship. So here we go, here's a right-tailed, so again, for the null, P is less than or equal to 0. And the alternative P is greater than 0. Why 0? Because remember when I showed you with R, 0 means there's no relationship. So you're basing all these on the idea that there's not a relationship. Okay? So now you have a test statistic T. Don't get this confused with what you did in 10.3. This is T just for regression. So if you look at it, T equals R over the square root of 1 minus R squared over N minus 2. Okay? Where R is your sample correlation coefficient from the calculator, N is your number of data pairs in the sample. N, the number of degrees of freedom for this has changed to be N minus 2. Okay? Rejection rules. These are very similar to what you saw in 10.3. So if it's a two-tailed test, reject the null if the absolute value of T is greater than or equal to T alpha divided by 2. A significant negative linear relationship, reject the null if t is less than or equal to negative t alpha. And significant positive linear relationship, reject the null if t is greater than or equal to alpha, t alpha. Okay, so let's do an example. Use a hypothesis test to determine if the linear relationship between the number of parking tickets a student receives during a semester and his or her GPA during the same semester is statistically significant at the 0.05 level of significance. Okay, so we're going to use this data below. So I'm saying that number of tickets is my x value and GPA is my y value. So I'm saying, okay, I'm trying to see if based on the number of tickets it affects how their GPA is. So go ahead and we're going to put that in our calculator. Remember, you're going to do it just like you did before, finding the R. So if you need to, go ahead and pause the video and put the data in for yourself. Okay, so if you're following along with us, we put the data in our calculator. All right, now from here, we're going to state the null and alternative hypothesis. They didn't ask if it was a linear, if it was a negative or positive. They just want to see if there was a relationship. So you're going to go with the two-tailed. So your null is p equals 0, and the alternative is p does not equal 0. This is very, very familiar to what you did in 10.3. Okay, so the next step is to determine which distribution to use for your test statistics. So you're going to use the t-test statistics that you used in this section. And we're going to test at the 0.05 level of significance. Number 3, gather the data and calculate the necessary sample statistics. We're going to begin with R. So let's go and see what the calculator gave us. So we put it in and we get R is negative 0.586619. And we know Rn is 15. So we're going to plug that into here. Okay? Be very careful putting this into your calculator. There's a lot of errors you can make. Honestly, I put it in one step at a time, so play with it. Make sure, you might have to play with it a couple times to get the correct answer. Once you find a way, you can always write it down, and that's your guide on how to do it. So when we solve this, we get t equals negative 2.612. So that's the t-test statistic. So then we need to compare it to our rejection rules. Well, remember, this was a two-tailed test, so we have certain rejection rules for that. So go use the T table, table C that we used back in 10.3. So the only difference is we're doing a two-tailed test, but our degrees of freedom have changed. Now they're 13 because we're doing n minus 2 equals the degrees of freedom. So go look at the table, and then we're going to get that our t critical value is 2.160. So we're going to reject the null if the absolute value of t is greater than or equal to 2.160. So since t is 2.612 and that's greater than 2.160, we can fail to it falls within our rejection regions. Thus we reject our null hypothesis. So we can say there is sufficient evidence to support the claim that there is a significant linear relationship between the number of parking tickets a student receives during the year and his GPA. Okay, so go ahead and play with these on your own and let me know if you have any questions. This is a good example for you to do probably step by step and see how you do with the calculator and figuring out the t-statistics. All right, so this ends this video and I will pick up later in this chapter. Thanks.